Hey everyone, it's that Math Magician, and on this video, I'd like to talk about the elimination method and how it's a great tool to use to solve a system of equations. Now, elimination method and substitution method can both be used in different scenarios. Okay, a substitution method, you want to use that when you have a variable isolated, right? When there's a variable all by itself on the equal side. Hopefully we can see with these two equations that I don't have a variable isolated. The x's and the y's are on the same side of the equal sign. And that tells us right away that substitution method is not going to work for us. Now, the reason why we like elimination method is because I can clearly see that my variables, my x's and my y's, are kind of lined up. They're lined up in a way where the x's are on top of each other, the y's are on top of each other, and then my constants are on top of each other. And that's a great indicator that you want to use elimination method. So let's write that down. Elimination method is great when your variables and your constants are lined up. Alright, let's get into solving this system by using elimination method. Here's how elimination method works. We have our two equations, x plus y equals -4, and negative x plus 2y equals 13. The goal of elimination method is to eliminate a variable. That's the whole point of this. So if we try to do elimination method and we don't eliminate a variable, then we've done something wrong. So let's look here. What I want to do with these two equations is I want to put a big plus sign on the side and a giant equal sign underneath, because I want to add those two equations together in hopes that we can eliminate a variable. Now, I want you to look at these two x variables that I see here. I have a positive x and I have a negative x. When I add these two equations together, I end up eliminating the x variable, because x plus negative x ends up becoming 0x. And so in an effect, what I've done is I've eliminated those variables. That's what we want to do. Our whole goal is to solve this problem, and we can't solve it when we have two variables floating around. Now let's look at the y variables. I have y plus 2y. Well, y plus 2y would end up becoming 3y. I bring down my equal sign, and now -4 plus 13 would give us positive 9. Now, I wrote down here the 0x. That can sometimes get a bit confusing, because if there is 0 x's, then there's no x's. I don't really need to write that. So what I'm going to do is I'm going to erase the 0x just to make it a little more clear on what our final equation ends up being. I now just have 3y equals 9. And that is a single equation with one variable that we can solve. And that's why we use elimination method, because I take these two equations that have two variables each. They both have x's, they both have y's. Well, if I can add them and eliminate a variable, I'm just left with a very simple equation. And I think we know how to solve this one. I want y by itself. 3 is multiplying the y. So why don't we go ahead and divide both sides by 3. My 3's on the left side will turn into a 1. And so I'm left with y equals 9 divided by 3, and that is 3. So I have solved for my y variable. Our next step is that we got to go back and get our x variable. And here's where you get some choice. You can either use the first equation on top or the second equation on the bottom. It doesn't matter which one you use. When I tend to choose what equation I'm going to use, I try to find the easier one, the one that looks like less work. And I think the first equation on top looks a lot easier and simpler than the second equation. So let's go ahead and use the first equation. I have x plus y equals -4. I'm just copying that first equation. Now, since I know that y equals 3, I want to use that fact to substitute this y value into our first equation. So I'm going to keep writing. I have x plus, But instead of writing my y, I'm going to write that y equals 3 because that's what we had solved. So I'm going to write plus 3 equals negative 4. And now I have an equation with one variable that I can solve. So since I have x plus 3, well, in order to undo the plus 3, I would need to subtract 3 on both sides. These 3's zero out, and I'm left with x equals negative 4 minus 3. That becomes negative 7. So now I have my y variable, I have my x variable. I can write my final answer as an ordered pair, as an xy coordinate, where my x is negative 7, comma, 3. Okay, please be careful when you write these. We solved for y first. We did not solve for x, so don't make sure you don't make the mistake of writing 3, comma, negative 7. That would be incorrect. Okay, it's always x, y. All right, now that we've solved and gotten our final answer of negative 7, 3, our last step is just to check our work. Because we have no idea if this ordered pair is correct, but we can verify it by checking our work. So just like we did with our substitution method, I'm going to rewrite my first equation, x plus y equals negative 4. And instead of writing my x and y variables, I'm going to substitute in my x and y values, negative 7 and 3. So let's go ahead. I have x, well, x is negative 7, plus my y, well, y is 3, and that equals negative 4. All right, we need to combine these, negative 7 plus 3, that just becomes negative 4. Bring down the equal sign, bring down the negative 4. And does negative 4 equal negative 4? I think it does. So this guy checks out. We know that our solution works for the first equation. Now let's go ahead and grab the second equation and see if it also works for that set. Negative x plus 2y equals 13. Again, I want to substitute in my x and my y values. Well, I have negative x. I know that x is negative 7 plus 2y, but I know my y is 3, and it equals 13. Again, I just took my x and y values and I substituted in the numbers for x and y. Now let's go ahead and solve this. Negative of negative 7, that just makes these negatives cancel and turn into positives. So I'm left with just 7 plus 2 times 3 is 6. Bring down the equal sign, bring down the 13. 7 plus 6 makes 13. And does 13 equal 13? I think so. So this solution that we found here, negative 7, comma 3, we know that that's the correct solution to this system because both answers here checked out. All right, hopefully this video helped demonstrate how we can use elimination method. Now, just for the record, this is a very simple application of the elimination method because our variables here canceled immediately. Okay, sometimes you're going to look at a system of equations and you're going to see that the variables are not going to eliminate right away. So you may have to manipulate the equation so that one of the variables drops out. And in my next video, you'll see how I'll do that. All right, guys, I'll see you next time.